So on our last ed puzzle and last assignment, we were talking about inequalities and solving inequalities. And what we're talking about today is compound inequalities. We're just getting a little bit more complex with our inequalities. So I wanted to remind you of a few things. One, when you're graphing inequalities, we were graphing them on a number line. What I wanted you to remember, though, is use a closed dot, right? For less than and equal to or greater than and equal to, right? It's got to also have that equal to line under it for it to be a closed dot. Otherwise, you're going to use an open dot, right? Which is just like a circle for either less than or greater than, right? Those are our two big things when it comes to graphing inequalities. I touched on a little bit before when we were talking about just inequalities was interval notation. And the reason I'm specifically bringing it up is because when we're dealing with compound inequalities, you are going to have to use interval notation in your Delta Math homework. If you have any questions about how Delta Math wants you to put in your solutions, make sure and watch the videos before you start. They always have like little how-to videos. So the couple things you're going to have to know is we're going to be using either parentheses, right? The parentheses indicate from this point to this point, but this is like our open dot. So it's saying that it doesn't equal anything on this side and it doesn't equal anything on this side, right? So this would be a true less than or greater than type of notation, right? When we have equal to, we will use brackets. Now, sometimes you're going to use both, right? Say I have something along the lines of x is greater than or equal to 8, and I need to write that in interval notation. Our interval notation on that would be 8, which we are including, so it's a bracket, but it would go all the way to infinity, which is a parentheses, because you can't be equal to infinity, right? You can just keep going. So sometimes you'll use more than that, right? And if I was going to graph that, that would be what? An open, closed dot at 8, like say at 8 right here. I'd have a closed dot, and it's greater than or equal to, and it would go forever in that direction. If I had, say, let's do something else that's kind of simple. X is less than -1, right? When we do this notation, it's a less than, so everything is going to be parentheses, right? Less than -1, well, it's everything that's less than -1, right? So we go from negative infinity all the way to -1. It is less than, so both are parentheses when we do our notation. And if we were graphing that, right, we would have a point at -1, but it would be an open dot going in the negative direction forever and ever. So I just wanted to remind you of that. We had one other rule that was a little different from equations, right? When we're solving inequalities, the main thing that you need to remember is is that if you are multiplying or dividing by a negative, you must change the direction of the sign of the inequality. Must change direction of inequality. So those are the biggest things that we learned in the last lesson that are going to carry over into this lesson. I was wondering why the words were so big on this. It's because the whole thing is out super far right now. And those rules are going to apply when we're dealing with compound inequalities as well. So what is a compound inequality? Well, a compound inequality is two or more inequalities that are graphed together on the same line, kind of like a compound sentence, right? We have an and or a but or an or in there. In this case, we're only dealing with and or. We have two types. So type 1 of compound inequalities, dealing with compound inequalities, we are going to deal with or, right? When we deal with or, it's always going to be written as two separate equations. So say I've got x is less than or equal to -4, or x is greater than 1. So those are two different statements, right? In interval, well, let's graph it first, and then I'll do interval notation. So here I've got this graph, right? We're going to say right here is -4, and right here is 1. I don't know how accurate that is, but it doesn't matter because these are graphing separately, right? Right now, we're saying x is less than or equal to -4. So x is this solid dot and everything less than it, right? X is also or greater than, so we don't have the line under it, so it's an open dot, or it's greater than 1 in that direction. Both of them graph on the same line, right? Both of these statements are true. When we write this in interval notation, this is where you have to pay special attention because we're connecting two things. So you're going to have parentheses, because notice this is going to negative infinity. It goes on forever, right? It's not equal to it. We're going to have negative infinity all the way up to -4, bracket, because we're including that -4. This symbol just means union. It means both of them are true, right? And now everything's open. This one's going to go from 1 all the way to infinity. And that is how we're going to have to write our interval notation. And getting that right is kind of important. Here's the thing, though. You're not always going to be given these specific problems. In some circumstances, you are going to have to isolate the variable and then graph it. So say I have, let's do an example. I have 3x plus 4 is less than or equal to 10, or, right? You know what kind of problem it is because it actually says or, 5x is greater than 45. So just like before when we were solving inequalities, we still have to get that x value by itself because that's what we're trying to find out what the trend is on. So I'm going to look at this and I'm going to go, well, I got to get that x by itself first. So I'm going to subtract 4 from both sides here. And I'm going to get 3x is less than or equal to 6. And then I'm going to divide out that 3. And I'm going to get x is less than or equal to 2. Right? So now we have our x by itself on that side, so we've got to go to the other equation. And the first thing we're going to do is we're going to divide by 5, because the only thing we have going on that x is it's being multiplied by 5. So we're going to do the opposite and divide by 5. And we get x is greater than 9. So we would know how to graph these each individually because you guys just did it recently and you're all pretty smart. And so I am going to do the graph here. This is an ugly graph because I didn't bother to bring out the ruler. But I'm going to call this 2, this 9. You know, you could do out a whole graph, but why bother? We only care about right now is 2 and 9. Think about in terms of what you're looking at, right? Both of these are going in opposite directions. Anytime you have an or, they're going to graph in opposite directions. You're going to have one going to the greater than, one going to the less than. So keep that in mind. Ors are always opposite from each other. So here we have greater, less than or equal to 2. So I would have a solid dot right here at 2 going in this direction. Here I have greater than 9. So it's not greater than or equal to. So I'm going to have an open dot and it's going to go in this direction. Right? So this is how we're going to graph these. Ors will always go in opposite directions. You're always going to have 2 separate graphs on there that go in opposite directions. Ands are going to have a whole different effect. Now, when it asks us for the interval notation, and it will ask us for the interval notation, we're going to look at this side right here. This side's going all the way to negative infinity. So I'm going to start with negative infinity, comma, and it goes to 2. It includes that 2, so it gets a bracket. In union with, that's what that means. Well, we have an open 9, so it's going to be parentheses. It's not including the 9, and it is going all the way to positive infinity. It gets the parentheses because if you've got an infinity, it's always going to have parentheses, not a bracket on the infinity side. Our next look is going to be at type 2 inequalities, which type 2, we're talking about and inequalities. And inequalities will have one common solution. They will graph into each other. And they will be written as one equation. So if you're given, for example, say you're given x is greater than or equal to negative 2 and x is less than 5. Sometimes you will be given the equation like this. Sometimes you will be given this equation as negative 2 is less than or equal to x, right? Same thing, right? X is greater than or equal to negative 2 is the same as saying negative 2 is less than or equal to x, and it is less than 5, right? And so this is a compound equation. We're making both statements the same. One thing to remember is that these will graph into each other. They have to have a common solution. That's what makes them and, right? If we looked at the or, they had opposite solutions. They had 2 separate solutions, right? But with and statements, they have a common solution. So when I graph this, see how straight I drew that line for the most part without actually having a ruler. When I graph this, I'm going to say, okay, this is negative 2. This is 5, right? When I go to make my graph, they're going to graph into each other. We're saying X is everything between these two. And you can tell because that X is between those two. I am going to have a closed dot on -2, right? Because it's equal to. I am going to have an open dot on 5 because it's just less than, right? Or greater than. And X is going to be everything in between. So our solution set in this circumstance is everything between -2 and 5, where when we were dealing with or, they were graphing away from each other. They had two separate solution sets. But these, if I were to write this in interval notation, it would be bracket, because we're including that -2, to 5 parentheses, because we're not including the 5, we're including everything up to the 5. Now, just like before, you're going to have different things that'll have to be done to these equations, right? Just like before, you're going to have to isolate those x variables. So in this case, let's look at what we've got. Here we've got I'm going to show you two types. So here, if I have 2x plus 3 is greater than -9 and 8x minus 2 is less than 30. Now, I can solve these on their own and figure out what my x's are, right? Before I make my compound equation. I can, right up here, that this is an example. So I'm going to start by subtracting 3 from both sides, and I get 2x is less than -12. And then I can go ahead and divide both sides by 2 to get rid of the 2. And we've got x is greater than -6. So we know that now, right? That x is greater than -6. Here, I'm going to add 2. I'm going to get 8x is less than 32. I'm going to go ahead and divide by 2 on both sides. And I get x is less than, I don't know why I'm dividing by 2. I'm dividing by 8. I'm losing my mind because I divided by 2 on the other side. Dividing by 8 on both sides, which will make my answer much nicer. X is less than 4. So these are my two things, right? When I rewrite that compound inequality, I can write it as -6 sorry, going backwards here. X is greater than -6, right? So I'm going to put x in between -6 and 4. Then when I go to graph this, it's a pretty good line too. I don't need a stinking ruler. So if I make this point -6 and this point 4, when we go to graph it, we have open dots on both of them, right? Because neither of them have the equal to. And they just connect together. We connect them. Ands connect, ors go away from each other, right? Sometimes you will get it as a compound inequality. So I want to give you an example of that as well. You'll get it already compounded. So this is example 2 of our type 2, where we're going to have 4 less than 3p plus 4 less than 19. And the idea is we need to get this p variable right here all by itself. So we need to undo everything being done to it. And so that is everything that is in here, right? It's being done to p. So the first thing I want to look at is this plus 4. And now when I go to remove it, I want to subtract 4 from here. but I also need to do it from this side and this side, right? We're doing two problems, but kind of at the same time. So this becomes 0 less than 3p less than 15, right? We still have 3 attached to this, and we need to divide out that 3 because it's being multiplied to it. I need to go ahead and divide everything by 3. I can't just divide one of these by 3. They all have to be divided by 3. Now, 0 divided by 3. Now, remember, I can divide into 0. I just can't divide by 0. I can't have 0 in the denominator, but the numerator is okay. This becomes 0, or it stays 0, I should say, is less than p, because these cancel, is less than 5. So now we already kind of have it in that form. We know that all of the solutions for p are between 0 and 5, and they don't include 0 or 5. They just go up to them, right? So here, when I put this in, I've got 0 and I've got 5. Your graphs on your homework will be fully numbered, so you just have to find the 0 and 5, right? But for the sake of actually making the graphs, we're going to go with 0. Well, we're going to have an open dot at 0. Let's pick another color. And we are going to have an open dot at 5. And because this is an AND statement, we're just going to connect them. And when we go do our interval notation is just going to be parentheses 0, comma, 5, parentheses, because we don't have any equals to, so there's no brackets. And our interval notation is just from 0 to 5. I hope that was informative. If you have any questions, please feel free to let me know. But that's really all I've got for you in examples. Your Delta Math assignment should help you practice, and I hope you have a great afternoon.